So this is the question 1 from the 2018 November paper, right? The final NSC paper 1 for maths. And it was for 23 marks, right? Usually the paper on question 1 ranges from 20 to 25 marks. Anywhere between there, you can expect that. And most of these things are grade 10 and 11 algebra, right? Equations, exponents, and things like that. And you'll see a pattern. It's the same stuff that they have to ask in that order. Yeah, pretty much. I'm just going to work through a few of them and let's get into it. So the first question will always be this basic one, your quadratic equation. So you just find your brackets, which should be in this case. So we're looking for factors of our c value whose sum gives us our b value. This case is my favorite. I like it when it's like this. It'll be -3 and -1. Sorry, -3 and -1. But bring that as our answer. Let's answer it properly then. As 1.1, we'd write, therefore, x minus 1 and x minus 3 is equal to 0. Now this system, this method rather, is on the principle that a times b is equal to 0. If a times b equals 0, therefore a must equal to 0 or b must equal to 0. Because for a product of two numbers to equal to 0, one of them, at least one of them, absolutely has to equal 0. Both of them can equal 0, but one of them definitely has to be 0. Otherwise, you can't get, you can only get a non-zero number as a product of two numbers when both the numbers are greater than or less than 0. Does that make sense? Because of the rule, because anything multiplied by 0, any number, will always give you 0. So one of the numbers that are multiplied simply has to equal 0. And when we reduce a quadratic equation, or any equation, to brackets and we equate it to 0, one of those brackets, because this bracket represents a number, a value, has to be 0. Therefore, x minus 1 has to equal to 0, or x minus 3 has to equal to 0. Therefore, x is equal to 1, or you have to use or here, not and, they don't accept that, or x is equal to 3, and that's how you get 3 marks there, right? For the next one is use of your quadratic formula. Hope you remember, you get a mark for stating x is equal to -b plus minus square root, and your discriminant, which is our delta, b squared, everyone's favorite, minus 4ac all over 2a. You remember this portion here for the nature of roots questions, right? Very, very nice. And moving on. Now, substitution, let's do that. This has to be written as your answer, right? That's 1.2. So substituting, -b is going to be 5 plus minus square root, b squared is going to be 25 minus 4 times a, which is 5, times c, which is 1, right? You can do it like that. And divided by 2a, which is going to be 10. You can put 2 times 5 even like this if you want. You can change this to 5 squared. If you're doing a direct substitution, that's okay. And just input this whole thing into your calculator, do it properly and precisely, right? It's better to get it right the first time because time is marks. And you say x1, because you get two x values, is equal to a number, to two decimal places as stated, and x2, whatever you can use or, is equal to, and two decimal places. So what you'll do is you'll type this in on your calculator separately. One time you'll block out the minus sign, pretend it's not there. The second time you will block out the plus sign, pretend it's not there. And that's just what you'll do. You get your two answers and you get your 3 marks, just like that. You don't have to show simplification, there's no mark for that anymore. And inequality. This one is x squared minus 3x minus 10 is greater than 0. So we treat this like a normal parabola at first, a normal quadratic equation, and we get x, now factors of -10, whose sum will give us -3, would obviously be -5, and +2, right? Greater than 0. Now we stop there, and we put this down. We say critical values. You can even just write, CVs. That's okay. That's also very acceptable. Now, critical values, now you can use an equals to sign. Okay, but up till this point, remember, this is important. Keep that notation, okay? Must equal to 5, or you can even use and here because we're going to use both points, right? We're going to use 5 and we're going to use the -2. But let's keep everything fine. And now you have your choice of methods. You can just do a simple parabola. You don't need to use ruler and all and be precise and no, don't worry. Okay, just and any like thing like that, even doesn't really matter. You can be as ugly as that. Don't worry. You just need these two here. It's the roots. -2, obviously you do it in ascending order of the root values. Duh, because negative becomes before the positive. If we had x equals 5 and x equals 7, you'll plot it 5 and then 7, 5 and then 7, right? You'll do it like that. You don't need to put your 0 and you draw your y-axis and all. You put arrows here. Don't stress. Don't stress. But anyway, so we have greater than, and greater than means above our x-axis, which means these values here, all these values after this line here, and everything before it, like so. Which means that we want this x is accounting for all the values here, and all the values here after 5, and all the values before -2 will be greater than 0 in this equation. And now we just need to state that. So we put our x down in the middle, and x has to be less than -2 and greater than 5, and that's your answer. You can also say this, x has to be an element of, but we're not including it, so you have to round brackets, -2 and 5. So what difference would it be? Let's do a turnaround. Okay, what difference would it make if our brackets were, if the question was this instead? What difference would that have made? Not much. The only difference, we just put a thingy there, because now we're including this point here. The second method, which I didn't show you, I'll do that now, is a number line. Again, you got -2, you can put a 0 there if you feel like it, and 5, right? And here we're not including it because the original question, so you put a ring and all our values that way, a ring, all our values that way. But if it was like this, right, with a line greater than and equal to, then we shade in our ring, because we're including that point, that x point, right? And then we'll use round brackets for this case. Sorry, we use square brackets if we're including it. Not inclusive means round brackets. Cool. So values between -2 and 5, not including -2 and 5. But that wasn't the question, right? Remember what the question was without the equal to. Next one is us solving our radicals. When you have radicals, we can square both sides. So yeah, we can do it here. The question was, I believe, 3 root x is equal to x minus 4, was it? Yeah, correct. Now, when we have x, sorry, if a equals b, it is absolutely correct to say that a squared is equal to b squared. Just as it is absolutely correct to say a cubed is equal to b cubed. Well, no, yeah, that is true, yes. And so on. Also, square root a is equal to square root b, and so on, right? It continues like that. So we can square this side equated to this side squared, and that helps us get rid of our radical. There's another way of solving it. I think you can use powers and k method and stuff like that, but it's easier like this, okay? It's much easier. I want to go into all of that, and so our answer looks like this. Remember, this is 3 squared times square root x squared. Why? Because ab raised to the power n is equal to a times n times b times n, right? So this 3 is also given a power, the distributive property of exponents, right? If you're bracketing both separately. So we get 9, and the square of square root x is just x is equal to, and here we squaring a binomial, x squared minus 2 times 4 times 2 times -4 times x is -8x, and -4 squared is 16. If you're uncomfortable squaring a binomial like that, the way I did using the rule, then you're most welcome. This is identical to saying, x minus 4 into x minus 4. That's perfectly reasonable. I just want to use FOIL. If you're comfortable doing that, no problem. Just use that, right? Whatever works, as long as you get it down to this eventually. And now what I want to do is I'd like to bring this over to my left-hand side. So I'm going to keep its values, x squared minus 8x. Then see, I'm taking my 9 over. So it's going to become -9x. And plus 16 equals 0. All I've done was swap the sides, okay? Because I like keeping my 0 on the right. It's just more comfortable like that, right? I mean, you can solve it with a 0 on the left, but like, weirdo, you know? So anyway, these two are like terms. So we have x squared minus 17x plus 16, and I see this is a theme in this paper, right? Now when we're factorizing, we have x minus 16, and we have x minus 1 equals 0, and we have x is equal to 16, or x is equal to 1. But are we done? No, we most certainly are not. One step, very crucial step that we're given marks for, is your resubstitution. So we substitute our two x values. You don't need to show it, you're right? You just need to um, reject one value by calling it non-valid, because we find when we did this, we did like a sorcery, we did like a trick, right? Like some kind of magic, and it's not always gonna work out. So one of these values that we actually found using our little magic trick of squaring both sides is wrong, woefully wrong, and we'll only find out by resubstituting. Let's try the 16. So 3 times square root 16 is 3 times 4, which is 12. And 16 minus 4 is 12. So this checks out. We don't need to go and resubstitute the next one because we know it's not going to be the one that's not valid. But let's just say that you chose to resubstitute the negative 1 first. Sorry, the 1 first. So you can be 3 times the root of 1, which is equal to 3 times 1, which is 3. And here we have 3 minus 4, where we have minus 1. Do you see why our magic trick didn't work? Because we took the square, right? We took the square. And when we're squaring, one side can be positive, one side can be negative. So it doesn't really account for that. Because look at this. Negative a squared is equal to b squared. But a doesn't necessarily have to equal b in this case, right? If the values of a and b are the same but opposite, right? Do you see that? Now, let's go on to 1.5, or is there 1.2 already? 1.2 already. Damn it, we ran out of equations. Okay, this is a simultaneous case. Simultaneous, this one is a pretty standard one, not on steroids or anything. What was it? 3x, yeah, 3x minus y equals 2. 3x minus y is equal to 2, that's our equation 1. Our equation 2 is 2y plus 9x squared is equal to negative 1. 2y plus 9x squared is equal to negative 1, and this is our equation 2. Let's work with this one. It's clearly our simpler one of the two. If you're a lunatic, you can work with the second one. That's fine. And I want to isolate my y. I think that would be easier. Look for what's easier. Okay, if we had x minus 75y is equal to 2. Now, don't be daft and try to make y the subject of your formula again. I mean, you can. There's nothing wrong with that. Mathematically, if you work it out properly, precisely, you can get it 110% right. But why do you want to do that and waste time? Okay, it's obviously easier to get a 1 as our coefficient, and we can do that pretty simply. So we simply say 3x, negative y, we bring our 3x over, is equal to 2 minus 3x. Therefore y, we switch all our signs. We're allowed to do that, multiplying everything by a negative 1, but I just call it switching signs, okay? Is equal to negative 2 plus 3, which is the same as saying 3x minus 2, right? It's the same thing. And we still call this equation 1. Why? Because we derived it from here, so there's no new information that we have going on here. Okay, it's the same information, just put forth a little bit differently. So there's no sense in calling it a whole new equation as such, because only here the values are differing. So we don't really need to change anything here. If you want to, you can, but we can go straight ahead and say substitute equation 1 into equation 2, right? We can go straight ahead and say that. And look, the value of y is this whole thing here. Do you see that? This whole thing is y. So when we're resubstituting, we'll say 2 into y, which is 3x minus 2, plus 9x squared is equal to minus, because every y that we see is carrying around a package, like a whole package of this expression 3x minus 2. Do you see the 3x minus 2? That whole package is being carried by the y. It's inside there, right? Kind of like that. And yeah, let's just highlight this so it's uniformity. And we use our distributive property of addition and in our brackets, and we say 6x minus 4 plus 9x squared is equal to negative 1. Yes, that's a 1. Don't judge me. Psst, your eyes are blind. It's your eyes, not my writing. Okay, I'm telling you. And now we have some like terms. Nope. Well, yeah, the -1 and the -4 are like terms. So we have 6x. Uh, we can see that it's coming to a quadratic. Okay, see, it's coming to a quadratic. So let's put it in standard form of a quadratic, starting with our highest power. Just for writing, we're not solving anything. See, we're not even thinking much. We're just putting things in a sensible manner. We're just rewriting stuff how we like to, following a simple set of rules. That's all. There's nothing crazy about it. And so we have 9x squared, our highest power. We're not looking at the 9, okay? We're not looking at the 9 and calling it our highest. We're looking at the index, the exponent. We're saying it's our highest power. We don't worry about the coefficients, okay? We can have 6,000x here, but we still put it after the x squared, just because, not because it's wrong to put it like this, but because it makes our life easier, right? And then that's plus 6x, because 6x is positive, and minus 4. But when we bring this minus 1 over, it becomes plus 1. Minus 4 plus 1 is simply minus 3 is equal to 0. Now here we're allowed to divide everything by 3 because, again, making life easy. See, we're not thinking about anything. We're not doing anything crucial. So let's save that higher thinking process for our level 3 and 4 questions, and let's just work simply and just do simple steps. Everyone can do simple steps, right, and get those marks. So dividing by 3, we get 3x squared plus 2x minus 1 is equal to 0. And now, again, I'm not even thinking, I'm just writing because I know that that's what I need to do. I'm not thinking highly as yet, and I just put an x here. Because 3 is a prime number, so its only factors can be 3 and 1, right? Does that make sense? So that's why, like, you can divide 3 by 2 and say 3 over 2 in one bracket and 2 in the other bracket, but that's just nonsense, right? Why you want to do that? Why? And I know 1 has to be at the ends of both brackets. Why do I know that? Because when we multiply our last, if we had to use for the multiply our last terms, we're going to need to get a minus 1 somehow. So there has to be a plus 1 and a minus 1. I just need to figure out which one it is. So see, I'm writing minus in both y, because once I figure out which one needs to be plus, I can just shrink and it's done. So again, it's not very little thinking used up in this whole 6-mark question. So you see, it's working smart, not hard. And which one needs to be negative? Well, I have a positive here. So my 3x, the one that's multiplying here, needs to be positive. So this can be a plus there. Because why? 3x minus 1x gives me 2x. And that's what we have as our middle term, the sum. Equals 0. One bracket times another bracket equals 0. One bracket must be 0. Therefore, 3x minus 1 has to equal to 0. Or x plus 1 has to equal to 0. Therefore, x must equal 1 over 3. Or x must equal to -1. Are we done here? No, there's one more thing to do. We need to find our y's. So we can say from equation 1, y is equal to 3x minus 2. From equation 1, so y must equal to 3x. Now this is the value of x. Now x has this carrying inside of it. 3 into 1 over 3 minus 2 was our equation. Or y is equal to 3 into minus 1 minus 2, and then we solve. Therefore, y must equal to 3 into 1 over 3. 3 times 1/3 is going to be a whole 1 minus 2, which is equal to minus 1. Or y is equal to 3 times minus 1 is minus 3 minus 2, which is equal to minus 5. And are we done yet? Almost, pretty close. We have our y values. Sorry. We need to write it as a set of polar points, okay? As a set of polar points. What does that mean? What does that mean? Well, like this. You know, your normal grade 9 point system. Our x value is going to be 1 over 3. Our y value came to minus 1 for that x value. Our x value is minus 1. Our y value came to minus 5 for that x value. And that's done. Now we have a non-routine, but this is a pretty okay one, okay? Because there's not really much thinking involved. There's just one thing you need to do. You need to make a link, okay? I'm going to pretend as if, yeah, no, it's fine. Let's just do it. 3 to the power 9x was, I'm just rewriting what they gave us, okay, is equal to 64. And 5 to the power root p is equal to 64, right? That's what they gave us. They gave us that, right? There's nothing for me to do. I just rewrote what they gave us. And they gave us this expression. They said 3 to the x minus 1 raised to the power 3, all divided by the root of 5, yeah, to raised to the power root p. I wrote it like that because it's more comfortable for me to understand, okay? Because it's not, don't confuse it with 5 to the root p. It's a different thing, okay? Look how it is. Now, the first thing that I would do, seeing this is the first time, which I did, is I would simplify this here. I don't like that it's just sticking out for me. Like, why? You know? So, I mean, why not? Why would you not go and do this and multiply this in here? Why would you not do that? Why would you not say this is equal to 3x minus 3? You know, our exponent laws, like, okay, what I'm saying is, and not if that you must know the law. I'm just saying it's something to do, because instead of just looking at it and thinking, oh no, I don't know the end. I don't know what's coming next. I don't know how on earth am I going to calculate the value of this? Is only letters. What's square root p? Oh my god. They gave me this. It's not the same thing. How is it going to work? Instead of thinking ahead, right? Think immediately. Focus on the step in front of you, not the whole flight of stairs, okay? As a brilliant, someone brilliant told me, don't focus on marks 8, 9, 10. Focus on marks 1, 2, 3. Just do. If you have, if you're seeing something, just do it, and it'll lead somewhere, and it is leading somewhere. And there's no reason to not go and do this. And already, actually, if you take the member, this the splitting is one whole mark, right? So you can get something instead of just thinking and panicking and stressing yourself out and writing nothing and leaving it blank because time is gone. Write something, okay? And yeah, so it's root 5 raised to the root p. And this is also equal, I want to split this up because it's making me uncomfortable because I can see something here. 3 to the 3x times 3 to the minus 3, isn't that so? Now the key here is to make a link between this and the given information. They'll always, the examiner is your friend, right? Guys, your friend. Yes, it sounds so false, like I'm lying to you, but the examiner is your friend. He wants you to solve the problem. Yes, he will hide certain things from you, but not so that you can't find it, right? Just you need to look properly, right? And look, yeah, it's in there. He gave you the information that you need, that you can use. What is the relationship between 3 to the power 3x and 3 to the power 9x? What do I need to do to 3 to the power 3x to get 3 to the power 9x? Easy. Raise this to the power, raise this to the power 3. Isn't that so? Which means that if I take the cube roots of this, because of our law, exponent law, a to the power b times raised to the power c is going to equal a to the power bc, right? Multiplication. This has to give me back 3 to the power 3x, correct? And we know that this value here inside my surd is 64. So my cube root of 64 is 4. 4 times 4 is 16 times 4 is 64, right? Is equal to 3 to the power 3. X is equal to 4. Brilliant, we're halfway done. This was a major step, okay? The next thing I would like to do is look at this. This is kind of cool. You can play around with it. Don't stress about it. Go off a little bit, go a little direction. Obviously, leave some time or space or something and come back to it if there are other easier marks to get. But play around a little, right? So here we can say the square root of 5. We agree that square root 5 is the same as saying 5 to the power half, right? Let me still have our square root p here. We agree. Square root 5 is same as saying 5 to the power half. Why? Because if we have a surd m a to the n, it's equal to, it's a law, inside over outside, n over m, right? Correct. So this is always a 2 in there. My inside is a 1, 1 over 2, correct. And ta-da! How do I get this to equal just this? Well, I don't quite know. I'm telling you, I don't know, but let's play around with it, okay? If I want to times it by itself, 5, 1 over 2 to root p. Oh, not even that. Let's just use the simpler law. Our multiplication law that we spoke about a bit earlier, right? Where we bring the power that was raised to into the brackets of the power of, yeah, inside there. So it's going to equal to 5 to the half p, or 5p over 2, whichever you feel, okay? I'll root there. Right, because we multiplied root p by the half. If we multiply this by itself, we get 5 half root p times 5 half root p. And if you look, our bases are the same. What is our base? 5. bases are the same, we add the exponents. You know, that's the first rule that we ever learnt of exponents. And that gives us 5 half root p plus half root p, which is in fact equal to just root p. Right? 1 root p. So multiplying it by itself, I'm saying that several times, multiplying this value by itself gave us this here, which is the information they gave. Multiplying by itself means squaring. So we take this and we square it, we get this. Which means that if we take the square root of this, right, we get root 5 to the power root p, like they gave us, which is what they gave us. We're linking it back to what they gave us here, right? You see that? What they were linking it back to that. Root 5 root p. So remember, we took the square root of this. The square root of this is equal to the square root of 64, which is equal to 8, equals to what they gave us, which was root 5 to the root p. Following? Therefore, this must equal to that, right? Do you see that? Just some investigation. Maths is magical, okay? And we found that this to be root of 64. Okay, so we let's write everything down. See here, this form here. No, we use our own form because we did some magic to it, okay? We said it's going to equal to 3 to the power 3x, okay, times 3 to the power negative 3 divided by root 5 to the root p. And we said we know this value here. We found it. How we found it? Because we did some investigation. And we found that this was actually equal to 4. Okay, we took its square root and whatever, or cube root and whatnot, and found it's equal to 4 times 1 over 3 to the power 3, which is 1 over 27. Just simplifying things to make it easy for me, right? And this root 5 to the root p we found to be 8. And look there, we get 1 over 27 divided by 2. Yeah, they cancelled, we got 2 and 1, right? Which is equal to 1 over 27 divided by 2, which is 1 over 54, and this is your final answer. So the value of this is 1 over 54. So what did they want to see? They wanted to see you put that exponent in there. They wanted to see you split this up, and they wanted to see if you could find the relationship between that 3 to the 3x, and this 3 to the 9x. Then they wanted to see if you could spot the relationship between root 5 to root p and 5 root p. And look what a nice number they give us, 64, which can be found the cube root of, which can find the cube root of, as well as the square root of. So, yeah, it's kind of a pleasant question. I didn't see the answer at first. Obviously, I didn't know this was going to be anywhere near 1 over 54. But it just work with it. Just break it up and just write. Okay, the first thing you do is just write. No matter what, just write. Look at all of this. Obviously, in your exam paper, it'll follow with some logic, but even this, I'm sure they'll find marks in there, so don't stress. And that is how you can get 23 marks, right? 23 marks. Now, I just want to show you something. This question here. 1 second. So I've given you square root, or rather function, f of x is equal to the square root of 3x minus 5 divided by x minus 3. And I'm asking you for what values of f of x, for what values of x is f of x undefined? What I'm asking is what number must be yeah or yeah, right? In order for this thing here to be a no solution, undefined, can't solve, mathematically unknowable, right, basically. And what you do for that? Well, there's not playing around needed. Let's just take it for what it is. When will something be undefined? Just think, grade 8 maths, grade 7 maths, okay? When will something be undefined? When you divide by 0. When you divide something by 0, when you put something upon 0, when you put something over 0, it will be undefined. We cannot divide by 0. Or we cannot take the negative inside a surd, right? But you can, that's working in complex numbers, but that's not in our syllabus, right? but for all intents and purposes, it's still undefined, right? There's no definition prescribed to it. So when there's a negative something inside a surd, so this answer will be for when inside the surd there's a negative. So inside the surd there's a negative. So when 3x minus 5 is less than 0, or when this denominator is equal to 0. Whenever your denominator is 0, your function will be undefined, right? And our denominator is 3x minus 3. When x minus 3 is 0. So when this is less than 0, why less than 0? When it's negative. Anything less than 0 is negative. And we solve, and we get x is equal to 5 over 3. Not equal to, sorry. Yes, x must be less than 5 over 3. And when x equals 3. So when x equals 3, this function will be undefined. When x equals 5 over 3, this function will be undefined. When x is less than 5 over 3, right? X can be 5 over 3. But x cannot be less than 5 over 3, and x cannot equal to 3. So we can say, but they're asking for which, if they ask which value of x is f of x defined, then you'll state the opposite. It's defined for when x is greater than 5 over 3. So any number greater than 5 over 3, but x cannot equal 3. And yeah, that's a bit of maths knowledge just